answers out there. Who would like to share their answer with me for the domain and for the range? Or just the domain. We can do just the domain. Jillian, I'm going to pick on you because I know yours was correct. What's my domain?
X such that X exists in all real numbers.
Yes. X such that X exists in the set of real numbers. So remember, we are in our set builder notation, so make sure you read the directions. And the set builder notation is when we have those braces and we have the line. Remember, instead of a line, you could also put a colon, and that would work as well. For my range, who wants to give me my range for 1A? McKay, I know yours was correct. Tell me what the range is.
Y such that Y exists or not exists equal to 3.
Yes, less than or equal to 3. So notice that we kind of think about what our max is there. The highest we can go up is 3, and then anything below that is fair game. Alright, part B. Do we touch all the X values? Yeah. And remember, most of the time that's something we expect. And we kind of talked about the fact, too, that it almost gets a little nerve-wracking to write all real numbers so much. It's like taking a true-false quiz, right, and writing true all the time. Like you kind of start to get nervous, like, can it be this solution so many times? It can. A lot of times our domain is all real numbers. Okay, I saw some people who had this one. This one was a little tricky. What do we put for the range? Go ahead. Equal to 4. So it lives at 4 all day long. It's not going anywhere else. So this would be y equals 4. Questions about 1 and 2? Or not, I keep saying 1 and 2. 1A and B. Okay, go ahead and erase. We're going to do the next. Okay, let's head onward here. When I look at the domain and range, remember we've got in interval notation, we've got parentheses or brackets. You could even have a parenthesis with a bracket, so there are different combinations of things you could have here. Remember, the parentheses mean that you can't get to that thing, like it's not truly included, and the brackets mean that it is included. 2A, the domain. Who's got an answer for me? Andrea, I know yours was right, so I'm going to make you give me the domain.
The domain was for the first one.
Sorry, for 2A, for the domain.
2A. The domain was negative and positive infinity.
Good. And what symbols did you have around those?
Parentheses.
Parentheses, agreed. Okay, so we can't truly like get to infinity. That's not a thing we can like reach out and attain, so we've got parentheses around both of those. Who's got a range they feel good about? Monroe, I'm going to pick on you. I know yours was right. What did you have?
I had a bracket.
Yeah.
And -4.
Mm-hmm.
And positive infinity ending in a
Yeah. And notice that I'm being, I'll call it lazy. Or maybe it's just time conscious. I don't know. You could spin it either way. But do you see how I'm not writing the positives in there? You don't have to write the positive infinity. You do have to put the negative in though. Okay, so that's important. Number 2, part B, the domain and range. What do we think? Elijah, what do you have for the domain for part B? I can see yours and it's right. You got it. And parentheses around both, just like we've been doing. And then, what do you have for the range? I can see your range too. Tell me that one too. You got it. It's the same thing, right? So what that means is in terms of X, we're going to touch everything left to right. In terms of Y, we're going to touch everything up and down on the graph. Alright, so we're kind of categorizing things. So we went through graph A already, and we're thinking about each one independently. We thought, is it one-to-one? The answer was yes, because it passed the vertical line test. Is it discrete? No, because it's not just a bunch of points. Is it continuous? Yes, because I could draw it in one swoop. Who wants to talk me through graph B? So same question. Okay, you guys, I'm gonna pick on you because I know yours is right. Is it 1 to 1?
Yeah.
Yes, because there's no double up. So it wouldn't be 1 to 1, say, if there was another point right below one of them. So is it 1 to 1? It sure is, because if I drew vertical lines, they would only hit 1 point each time. Is it discrete? Is it continuous? No. Perfect. All right, graph C. Who wants to help me with graph C?
What's the vertical line test?
The vertical line test. So the vertical line test is when you pass vertical lines through the graph, like this. If the vertical lines touch more than once at any place, then it's not a function. So an example of something that would fail the vertical line test would be a circle, because if I were to draw a line through, it touches at 1, 2 locations. So think about the name where it says 1, 2, 1. So each one line touches the graph 1 time. So 1 to 1. This is 1 to 2. So it's not going to work. Does that make sense? Okay. Who wants to help me with part C? Go ahead. Tell me, Isla.
It's 1 to 1.
It is 1 to 1. Is it discrete?
No.
No. Is it continuous?
Yes.
Yes. Perfect. So C fits in those 2 spots. Last one is part D. I think a couple people maybe even missed this part because it was so far removed from the graph. So make sure you see that there. Does anybody want to help me with graph D and tell me where it fits? Andrew, go ahead.
It's not 1 to 1.
I'm gonna get you on that one because you see how this one's open and this one's closed. So that's actually okay. So it is 1 to 1. Keep going though.
It's not discrete.
I agree.
Lines, but it's not continuous either.
Yeah. So if discontinuous was an option, you would say yes. And I don't know that we have them like this when we've done the 1 to 1s before. So that's a good one to have up there. It's a tricky one. Again, it is 1 to 1 because the open circle and then the closed. If they were both closed circles, it wouldn't be 1 to 1 because both points would be included. So if this was filled in, it would be no for 1 to 1. But because it's open, it's okay. Okay, so if you had to explain to a friend what an x-intercept is, what is it? Where your graph what? Yeah, crosses over the x-axis. So I actually had a teacher back in school 5 million years ago, and she always made us write the x and y in so we remembered which axis was which. So there's my x-axis. I have 2 x-intercepts based on that definition. Where are they? 2, 0 is one of them. And 7, 0, let me see. 1, 2, 3, 4, 5, 6, 7. I agree. 7, 0. Thank you, Isla. Okay, in terms of y, the y-intercept is where my graph would touch the y-axis. So this one is not left or right any, but how many is it up? Good. I need you guys to confirm it. You have those young eyes and you can count them better than I can. What's up?
Oh, why is it like negative on X? Why isn't that intersect? Like what X?
Oh, because I don't know. We need one more x-intercept. Because I didn't draw it in, and I didn't think about it until just that moment. That's why. I have no better reason. Okay, now that I drew in the lines, where does that x-intercept live? -3, 0. I think the reason is because when I was making the problem originally, I was thinking about these 3 points, and I was, yes, that is truly an x-intercept, though. Good question. Thank you. Alright, next one, erase. Felt like this was a good season for Honey Crisp apples. Honey Crisp apples. Okay. So for this one, I see a little more confusion because it's not quite as like given of a problem. Like there's more up in the air here. So the first thing I did, I drew this on the board, but I wanted to be able to put it under the dot cam as well. So when we're buying apples, we can't buy negative apples. We talked about that. That sounds weird. That's not a thing. We can buy 0 apples. If we buy 0 pounds, the cost would also be 0. As we buy more pounds of apples, the cost is going to increase with us. Did somebody write an equation they think might work for this? A y equals equation. Go ahead.
Y equals 299x.
Yes, I love it. 299x. Now, let's put that graph back up there. Can I draw this in one swoop without picking up my pencil? Yes. So this would be continuous. My domain. It didn't tell me how to, did it tell me how to write it? Set builder notation. Okay. So we've got x such that. What does x have to be? Did negative apples make sense? No. Bless you. Greater than or equal to 0. Let's think about the range. What would the range be? Yeah, same thing, right? Greater than or equal to 0. So again, draw yourself a sketch. Do you need to make it perfect and have like all your points plotted? No. But you can draw yourself a sketch, and that really makes a difference when you're thinking about domain and range. So that might be something to think about doing tomorrow. So remember, think about some of these strategies and ideas that we're using and applying them also tomorrow. Okay, erase. Ready for the next one? Oh, if you're wondering how many questions, that's also how many questions. There are 9, and you just did 5. Okay? These last couple are going to be quicker though, so we're way more than halfway done. Identify the type of symmetry. Ooh, what were our types? What are the choices? Line, point, or neither. Line, point, or neither. Part A, line, point, or neither. I feel like you could go either way with that one. I feel like I drew it kind of not amazing. Did anybody put point symmetry? Yeah, I was going to say I would go with point, or because of my terrible drawing, I would go with neither. I would say either of those are fine answers. My goal was that it would be point symmetry, and that if you took this arm of the graph and rotated it 180 degrees, it would land on top of itself. So my goal was for it to have point symmetry, but I realized just because of how stiff this side looks that it maybe doesn't match that side quite as well. So again, you put neither because of Miss Bussel's bad drawing skills, that is okay. I'm fine with that. What about part B? Line. So line is what I was going for here because a line would cut it in half. Alright, erase, yeah, no, you can erase. I have kind of a continuation on those questions though. So think about 6A. Write down your answer. I'm not even going to pause the video because this should be a quick one. So for 7 and 8, they should be pretty quick. So is the graph for 6A odd, even, or neither? Is the graph for 6B odd, even, or neither? So write down your answers. What do we think about A? I want it to be odd, but even if it had point symmetry, is the point symmetry at the origin? No, so this one's neither. So even if we agree that it has, oops, let me circle it down here. Even if we agree that it has point symmetry, in order for it to truly be odd, that point symmetry would have to be at the origin. So again, point symmetry would have to be at the origin, and it isn't. So it doesn't fit that definition. How about number 8? So now we're looking at B. Odd, even, neither. Even is correct. It is line symmetric, but it's also even beyond that because the line of symmetry is the y-axis. So almost think about this as like an extra step that you have to take. So not only does it have to have point symmetry, but it has to be at the origin. Not only does it have to have line symmetry, but it has to be at the y-axis. So it's almost like taking it a step further when you're thinking even, odd, neither. Okay. Last one, erase and try this one. End behaviors. This is the one, let me give you a starter. This is the as x approaches positive infinity, y does something. And we're going to fill in the blank for y. As x approaches negative infinity, y does something. So remember, we write this much every single time, and you need to fill in the blank. Here we go. As I approach positive infinity for x, remember, this means as I go to the right. What is my y value doing? Going up. Positive infinity. As I go to the left, what's my y value doing? Going down, which is negative infinity. And that negative infinity looks okay. Same thing for this one. As I go to the right, what's happening? Going down. How about as I go to the left? Also going down. Going down. Beyond what we just talked through together, there's one other idea that I want to make sure you study that's on the quiz above and beyond all this. Make sure that if I gave you a data set, you could find the x and the y intercept. Let me show you what I mean. So let's say you had, I'm going to steal the idea that they used in the story problem. Let's say you had a gift card, and the gift card started with $100 at week 0, and then you went shopping, and now it's at 80, and 60, and 40, and 20, and 0. Oh, I almost ran out of room. 2, 3, 4, 5. What would your x-intercept be? What's your x-intercept? 5, 0. So remember your x-intercept, so this is my x-intercept. Your x-intercept is always when y equals 0. So again, if we go with the pretend story that I just made up of the gift card, because I stole it from the problem that we had in the notes, after 5 weeks, you have $0 left on your gift card. So not only is it going to say what's the x-intercept, to which you would say 5, 0, but then when it says, well, what does that mean or represent, it means after 5 weeks you have $0. What's my y-intercept? 0, 100. And that represents, at time 0, I have $100 on my gift card. Does that make sense? So that's what this is asking. So, I'm going to post